We might find alien life soon. NASA's plutonium-powered drone bound for Saturn's organic moon. This is Saturn. It's encircled by an exquisite system of rings. A six-sided storm, still not fully understood, rages on its north pole. And it's orbited by more than 250 moons. Now, all moons are special, but some moons are more special than others. Meet Titan. Droplets of liquid hydrocarbons rain from its thick, smoggy atmosphere. Those droplets flow through hydrocarbon rivers, which collect in vast, frigid hydrocarbon seas. Titan is an organic world, which might help us answer one of the biggest mysteries of all. Are we alone in the cosmos? In this video, we'll explore this most marvellous of moon and then look ahead to the 2030s at the nuclear-powered drone NASA is sending there. It's easy to overlook moons because they're often cast as sidekicks to their planets. But take a closer look and you'll discover that they're every bit as dynamic and diverse and delightful as the planets themselves. Some of them, like Jupiter's Io, have volcanoes, and many of them, such as Saturn's Enceladus, are made from water ice. But Titan is a standout. It's the second biggest moon in the solar system after Jupiter's Ganymede. In fact, it's even bigger than the planet Mercury, which means if Titan orbited the Sun instead of Saturn, it would be a fully fledged planet. The first hint Titan was special came in 1907, when astronomer Joseph Comasi Solas noticed a phenomenon called limb darkening. This is a very slight fuzz and a dimming surrounding the moon, hinting that it's surrounded by something like an atmosphere. Then, in 1944, Kuiper, yes, that's the Kuiper Belt guy, discovered something completely unexpected using a spectroscope. Methane, an organic molecule. This is the original spectrum he published the same year he made his discovery. The apparent fuzz and the organic chemistry hinted towards something tantalizing. An organic atmosphere, chock full of hydrocarbons. What was it like? Does anything live there? What exactly lay beneath the clouds, if the clouds even exist? Nobody knew for sure because from Earth, Titan resembled an orange smudge. But that all changed in 1979 when Pioneer 11 became the first spacecraft to visit the Saturn system. It photographed Titan and confirmed beyond all reasonable doubt that it does in fact have an atmosphere. In fact, Titan is the only place in the solar system aside from Earth that's got a thick atmosphere. Now, Pioneer 11 was too far away from Titan to reveal much in the way of detail, but it was clear the atmosphere was extensive and complex. And shortly after Pioneer, we had the Voyager twins, Voyager 1 and Voyager 2. Voyager 1 flew past Titan in 1980 with instruments at the ready. It revealed the chemical composition of Titan's atmosphere to be truly alien. It's made from mostly nitrogen, with wisps of methane, acetylene, ethane and propane, and a cocktail of other organic molecules for good measure. It also photographed the upper atmosphere up close, revealing it in detail for the first time. But there was a trade-off. Titan's gravity deflected Voyager off course, high above the plane of the solar system and thus ending the planetary phase of its mission. Voyager 2 arrived a year later and took more spectacular images, made loads more measurements, before continuing its onward journey to Neptune and Uranus. And so by the early 1980s, Titan had gone from an orange smudge in the sky to a world in its own right. We knew it had a thick atmosphere, chock full of organics, but exactly what lay beneath the clouds remained a mystery. It would remain this way until we returned 23 years later. Enter Cassini, which slipped into orbit around Saturn in 2004 after a 7-year journey from Earth. Now, riding piggyback on NASA's Cassini was the European Space Agency's Huygens spacecraft, named after the Dutch astronomer Christian Huygens, who discovered Titan in 1655. Whilst Cassini was an orbiter, Huygens was a lander, destined for Titan's surface. On the 23rd of December 2004, Huygens detached from Cassini and hurtled towards the giant moon. For 2 hours and 27 minutes, Huygens parachuted through the clouds towards the icy surface. Winds buffeted the probe as it passed through layers of foggy nitrogen and methane, and then it broke through the orange haze to glimpse the world below. An icy surface, almost minus 200 degrees Celsius, crisscrossed by a braided network of river channels carved not by water, but by liquid methane. Huygens revealed Titan's intricate hydrological cycle based on liquid hydrocarbons. And much to the surprise of the engineers who built it, it survived. And at that moment, Huygens became the first and still only spacecraft to land on a world in the outer solar system. This is Titan's hydrocarbon surface, as seen by Huygens on the 14th of January 2005. That frigid landscape is made from ice and it's laden with hydrocarbon mush. Huygens sat on the surface for an hour and 12 minutes until, with its battery running low, the lights went out. But high above, Cassini orbited Saturn for the next 13.5 years. Cassini revealed dunes of hydrocarbon sand, the occasional impact crater, and hundreds of lakes and seas, the largest of which, Kraken Mare, is bigger than the Caspian Sea. And using its onboard mass spectrometer, Cassini unpicked the chemistry of Titan's upper atmosphere. It detected complex organic molecules with up to 6 or even 7 carbon atoms in their structures. Together, Huygens and Cassini cemented Titan's reputation as somewhere that might be able to harbour life. Even if Titan is a sterile world, the scientific consensus is that it's probably at least prebiotic. It resembles the kind of place where life could originate. And in this sense, it might resemble something like the conditions on the young Earth in which life did arise. Titan pushes the edge of the habitable zone around the sun far beyond the warmth of the Goldilocks zone, all the way into the outer solar system. Now, by 2017, Cassini was running out of propellants, and without any rocket fuel, its orbit would drift. Now, mission scientists were fearful that Cassini might crash into Titan and contaminate it with stowaway microbes from the Earth, thus contaminating a pristine environment, and so they took no chances. They sent Cassini on a nosedive into Saturn itself. Cassini burned up and vaporized like a meteor as it plunged through the clouds on the 15th of September 2017. 13 years and 2.5 months after arriving. Now, we haven't been back to Saturn since Cassini, but that is going to change in the mid-2030s. In the summer of 2028, if all goes to plan, NASA will launch one of the coolest missions ever to leave the Earth. Dragonfly. The spacecraft will arrive in the Saturn system in the mid-2030s and touch down on Titan's surface. Or perhaps aircraft is a more appropriate descriptor for Dragonfly, because once it lands on Titan's surface, it will take off again because it can fly. Unlike Huygens, Dragonfly won't be stuck in one space. In the engineering parlance, it's a rotorcraft, capable of taking off and zipping through the air. Or I guess zipping through the hydrocarbons would be more accurate. Titan's low surface gravity and thick atmosphere make it the perfect place for powered flight, easier in fact than here on the Earth. 8 spinning blades will carry Dragonfly from place to place as it scouts new terrain and makes measurements. Now, this mission, being NASA, is incredibly ambitious. For 3.5 years, Dragonfly will explore a region called Shangri-La, a vast equatorial field of dunes sculptured from organic sands. It will traverse a distance of about 180 kilometers over many individual flights, culminating in a visit to Selk impact crater. There's strong evidence that Selk once harbored liquid water, which, combined with the organic chemistry that covers Titan's surface, makes it a strong candidate for a concoction of prebiotic chemistry, or perhaps even life. And Dragonfly is surprisingly big. It's about the size of a car, which leaves plenty of room for a suite of scientific instruments. A mass spectrometer will measure the molecular weights of Titan's organic medley. A gamma-ray and neutron spectrometer will measure the composition of the surface. A weather station will track the wind and record the temperature. And a bank of cameras, ranging from the panoramic to the microscopic, will snap the sweeping vistas and even capture details down to individual sand grains. It's really no stretch to say that Dragonfly is a flying science laboratory. All of these instruments require electrical power, but unfortunately 900 million miles away from the sun, way out in the dark outer solar system, solar power just won't cut it. As such, Dragonfly will be nuclear powered. Dragonfly will carry almost 4.5 kilograms of plutonium-238, a rare and unusual isotope that is so radioactive that it literally glows red hot under its own radioactive decay heat. A thermoelectric generator will transform this decay heat into usable electricity that will keep Dragonfly and its instruments alive. It's the same kind of power source that electrified the Interstellar Voyager probes, the Mars Perseverance and Curiosity rovers, the New Horizons Pluto Explorer, and, on brand for Saturn spacecraft, Cassini. And so, there we have it. A plutonium-powered, car-sized science laboratory that can fly, bound for Saturn's moon Titan in search for life, or at least prebiotic chemistry. Dragonfly will redefine what robotic space exploration can look like, and I cannot wait to see what it finds. If you enjoyed this video, you should know that I put it on my Substack way ahead of time, drtimgregory.substack.com. It's completely free to read, and I'll be posting lots there in the coming months, so head on over to subscribe. Until next time.